Hello, AP Physics students. We're going to talk some vectors here today. It's Mr. Kirsch coming at you. Vectors. I'm excited. Let's get started. Okay, so let's break every quantity we're going to study this unit into one of two categories, scalars and vectors. Okay, so what is a scalar? A scalar is a number with a unit. So an example of a scalar is temperature. When you talk about temperature, you might say 17 degrees Celsius. Okay, so temperature is a scalar quantity. Time is a scalar quantity. I might talk about 60 seconds, right? This video might be gone in 60 seconds. Actually, it's be gone in about 10 minutes. But anyway, time is a scalar. Mass, 86 kilograms, a number and a unit. Mass is a scalar quantity, all right? And now, in comparison to scalars, we have vector quantities. Vectors are things that always have a magnitude and a direction. So there's a number and a direction associated with that number and unit. So, for example, velocity is a vector quantity. If I were to say 12 meters per second northeast in a northeasterly direction, that would be a vector. There's a number and a direction associated with it. Force. If I were to say 3.14 newtons in the positive x direction, right, or along the plus x axis, that would be a vector quantity, right? Magnitude and direction. 9.81 meters per second squared downward is a vector quantity because there is a direction associated with my number and my unit. All right. So things we're going to study in physics are either going to be scalars or vectors. All right. Okay. So let's talk about how we might represent vectors. Okay. Mathematically speaking, we draw vectors like this. If I were to draw vector A, okay, I might draw it like this. The length of my arrow here, my vector, is the magnitude, all right, magnitude and length. And then, of course, the vector has a particular direction it's pointing. If I want to call this vector something, I might call it vector A. Vectors in your book will be in boldface type, but when you're writing out vectors in your notebook, you can't write in bold, so you write a little arrow on top of them. So I would say this is vector A. Now, vectors have a particular length or magnitude and a particular direction, but they don't have a particular location in space. So while this is vector A, if this is the same direction and same length, then this is also vector A. All right. And I might have another vector. This might be vector B. All right. Notice it has a different length and a different direction. So that's how we draw vectors. By the way, the arrow, the tip of the vector, sometimes we call that the head, and sometimes the bottom here we call the tail. All right. So head of the vector and tail of the vector. Okay. What else can I tell you? A lot of times we will take a vector and break it up into its x and y components. So if this is vector A, okay, this would be vector AX, and this would be vector AY. A component vector is always parallel to the axis, all right? So AX is always horizontal like this. AY would be vertical like this. And we say AX and AY are the components of vector A. Okay, let's talk about vector multiplication. I can multiply a vector by a scalar. So for instance, while this is vector A, this would be vector 2A. Okay? And guess what? Vector 2A points in the same direction that vector A is, but it's twice as long. Okay? I can also multiply a vector by the number -1. This is vector -A. It has the same length as vector A, but it points in the exact opposite direction that vector A does. Okay? And I could have vector -3A, right? I would point in the opposite direction and be 3 times as long. So I can multiply a vector by a scalar. How about adding two vectors together? There's a couple ways in which you can add two vectors together. One method you can add vectors together is by the graphical method. Okay? And here's how you add together two vectors by the graphical method. If I want to figure out what is A plus B equal to, let's say it adds whatever it is, let's call it vector C. What I would do is draw in vector A at the origin. Okay? I would then take the tail of vector B, put it at the head of vector A, all right? And then if I then draw in a brand new vector from the tail of vector A to the head of vector B, that vector is vector C, all right? So we call this the graphical method of addition, vector addition. Now if I wanted to know how long C was, I would have to get out a ruler and measure it. And if I wanted to know the direction of C, I would have to get out a protractor and measure this angle here. So the graphical method of vector addition is quick, right? It's easy to do, but it's not super accurate unless you have like graph paper and a protractor and that type of thing. Okay? So, what if you want a more accurate way to add together two vectors? Well, you can do the component method. And rather than drawing this, I'm going to refer you to figure 314 in your book on page 51. And here is the component method of adding together two vectors. So here I'm going to add up vector v1 and v2. And v1 plus v2 is equal to vector v. All right, so you can see they've added these two vectors by the graphical method already. And to add two vectors by the component method, basically you take the x component of your first vector, so this is v1x, and take the x component of your second vector, this is v2x, add those two vector components together, and you therefore get the x component of the resultant vector. So we would say v1x plus v2x is equal to vx, all right? Or ax plus bx is cx. And likewise, you would find, do the same thing with the y components. v1y plus v2y is vector vy, all right? So read through your book there and make sure you check out some examples of vector components. And then I am going to do an example problem for you here. And we're kind of running short on time. So I am going to just kind of show you the answer here, actually, to problem number 4. All right, so this is problem number 4 from your book. And here's what it says. There's a vector, and I don't know its magnitude or direction, vector v, but I know that Vx is 6.80 units long. Vy is negative 7.40 units long. What is the magnitude and direction of vector v? So I drew a picture here. Notice Vx points in the plus x direction because of the positive sign. Vy points in the negative y direction because of the negative sign there. So this is Vx and this is Vy, and this would be vector v. Now, if I wanted to find the length of vector v, or the magnitude, and sometimes if we're talking about the magnitude or length of a vector, we put these absolute value signs around the vector. This means only the length of the vector, right? And guess what? We would use our old friend, the Pythagorean theorem here, since this is just a good old triangle. And we would figure out that the magnitude or length of vector v would be 10 units. So I would say vector v has a length or magnitude of 10 units. And then to find the direction of vector v here, I would look at this triangle that I've drawn, and we would want to find this angle theta. All right, so using good old trigonometry here, I would say that theta, the tangent of theta, would be the opposite over the adjacent side, so that would be vy over vx. So theta then would be the inverse tangent of that. And if I plug that in to my calculator, I would get 47.4 degrees. Notice I just kind of solved for the angle theta here, assuming it's a positive angle. But then when I wrote down the direction of the vector here, I said that vector v's direction is 47.4 degrees below the positive x-axis. So sometimes people might just say this angle is negative 47.4 degrees, or it would be equally fine. I kind of prefer to say 47.4 degrees below the x-axis. Either way is fine, as long as you're definitely indicating the direction in a non-ambiguous way. So, vector v has a magnitude of 10 units, and its direction is 47.4 degrees below the positive x-axis. Nice work, AP Physics students. Here is your joke for being so good in listening to this video, and here it goes. Okay, what concert do the tickets only cost 45 cents? What concert do the tickets only cost 45 cents? Are you ready? It's 50 Cent featuring Nickelback. Get it? Get it? Because, if it's 50, cents, right? Featuring Nickelback, right? Nickelback, then the tickets are 45 cents, right? Because 50 Cent featuring Nickelback. All right. That's work, AP Physics students.